Hello and welcome to our webinar on MCAD optimization for VR, AR, MR applications. My name is Kristen Gray, Global Marketing Manager for ITI. Please keep in mind you will be muted the entire webinar. If you have any questions, please direct those to the questions window or raise your hand if you need help. We will have a poll question. When you see the poll question, please weigh in quickly and then we will present the results. After the webinar, I will send out a link for you to rewatch this presentation. We will also hold a Q&A session at the end, although if you have any questions during the webinar, please feel free to direct them to the questions window. Thank you for joining us today. Today's presenter is Steve Uterdijk, Senior Technical Specialist. Steve, I will turn things over to you.
All right, thank you, Kristen. Again, my name is Steve Uterdijk. I've been with ITI for over 22 years, delivering multi-CAD interoperability solutions focused on downstream data reuse. During that 22 years, I've been the North American lead for the CADfix product line, of which today we're talking about CADfix Viz. So the value proposition for CADfix Viz is that it's designed to optimize 3D CAD model assets for downstream reuse in virtual, augmented, or mixed reality software applications and hardware devices. Designed to increase the VR, AR, MR application connectivity and interoperability, and ultimately to save time converting and repurposing MCAD data for these VR, AR, and MR applications. Kristen, I think we were going to do the poll now.
Yes, so we'll go ahead and launch that. So you should see that shortly. The poll question is, what AR, VR, MR systems are you using? Unreal, Unity, something else, not using AR, VR, MR yet. We'll give you just a few seconds to go ahead and weigh in, and then we'll close the poll here shortly. If you've not weighed in, please do so. All right, I'll give you just a few more seconds, and then we're going to close the poll. Okay, closing the poll. And it looks like for the results, Unreal had 0%, Unity had 17%, something else 17%, and not using AR, VR, MR yet 67%. Steve, I'll turn it back to you.
Okay, great. So we have a lot of maybe potential users of this technology in the future. Hopefully what I present today will be some use to that when you do adopt that technology. So key functionality points for CADfix Viz are multi-CAD and mesh imports with support for not only native CAD formats, but standalone standard CAD formats such as step and modeling kernels like Parasolid. Intelligent model simplification to remove unwanted features and internal parts. A high quality and robust mesh generation in the internal engine of CADfix Viz. Export to optimize lightweight mesh formats common to the AR, VR, MR workspace. An easy to use intuitive interface and the ability to do all this with an automatic conversion that also includes batch support if desired. So this is just an example of a model optimization. You have a complex BREP CAD model on the left-hand side, a complex assembly most likely. So that's the actual geometry. Just out of the box, producing a mesh, facetization mesh on that model creates a mesh of over 420,000 triangles. So good resolution, very complex, a lot of small intricate parts in this. And then on the right, an example of a defeatured mesh that results in a significant reduction in the number of triangles and mesh density down to less than 9,000 triangles. So when you get down to your VR type application, this is just going to result in faster speeds, less hang time, and just easier to work with as you incorporate possibly multiple models into that virtual reality space. Another example here, this is a fully automated solution within CADfix Viz. So basically we have the concept of different levels of detail. So the program can hold different meshes, a very robust, detailed, high density mesh, and then other representations that defeature that mesh and make it a simpler, more lightweight, easier to handle mesh. So again, the complex BREP CAD model, the first level of detail, LOD 0, has over 1 million triangles to represent it just out of the box, meshing that assembly as is. LOD 1, which takes some defeaturing options into consideration, has reduced it down to 211,000 triangles. And then LOD 2 is really where you can definitely see some simplification in the model, and that takes it all the way down to just over 22,000 triangles. So it's obviously a balancing act. How much detail do you want, but also a balancing act of how small can I make that mesh for quicker generation times in your virtual reality system. So we have multi-CAD and mesh imports, the native CAD systems we support, CATIA, NX, Creo, Inventor, Solid Edge, and SolidWorks, neutral CAD formats of STEP, Parasolid, JT, DXF, DWG, and ASYS. And then also you can just start with a mesh if that's what you're provided. So on the import side, we support FBX, GLTF, GLB, and OBJ. So within CADfix Viz is a very robust mesh generation engine, accurate, high quality, watertight mesh generation. The minimum number of facets is used to capture the geometry within defined tolerances, the goal being a minimum file size. The user has control over accuracy settings such as sag and turn values in the mesh generation. And then you also have the capability to mesh the whole model or selected parts or subassembly or whatever may be desired. So how do we reduce the mesh size and get down to these smaller mesh counts? One major part of this is defeaturing. So defeaturing tools are used to reduce the complexity of model, the ultimate polygon count, and ultimate file size. So removing unwanted parts. These may be very small bodies, your nuts and washers and screws that maybe you can drop from the representation and still capture the fidelity you need. The ability to remove internal features. So if you can't see those mesh parts from the outside, we can remove them. The ability to remove unwanted features. Features primarily being holes and protrusions. So depending on how many of those type of features you have in the model, that can definitely be a big benefit. The ability to wrap components. So essentially, kind of a shrink wrap, which gives you the most detail. We also have the concept of a convex hull wrapping of a body, which gives you less detail, but obviously much smaller file size and less polygon count. And then these simplification tools can be run automatically or interactively. So some examples of those, small bodies, basically a user-controlled tolerance is going to define what's small, what's not. If it falls within a bounding box tolerance that the user specifies, it'll be considered small, and that mesh part will be removed. The ability to automatically identify and remove internal components, also ignoring kind of a gap that may be in that outer shell. So maybe everything is basically not visible, but there are some small gaps in that outer shell. The user can specify essentially a tolerance to span over that gap and still consider that shell closed off and everything internal. So identify those interior mesh parts and remove them. And then unwanted features. This is an example of holes. So you can see just in this one part, the removal of holes right off the bat took our mesh from nearly 8,000 triangles down to a little less than 3,000 triangles, just removing all the holes in the model. Holes are always going to drive up the complexity. You got to have the detail in the mesh to capture that rounded curvature of the hole and then transition away from the holes. So removing holes can usually give you a big payoff in polygon count reduction. This is an example of protrusions. In this case, basically the protrusion is the writing on this part. Holes as well as protrusions can be filtered by shape and by size. So in this case, we have an example of this writing falling under the selection criteria of size, being identified as protrusion and then removed from the part. You can see the reduction and how much simpler the mesh is by doing that. The wrapping that I was talking about, the wrap options span from a shrink wrap, which has the most detail. Basically, just what it says, kind of a saran wrap, shrink wrap of the model, and then the mesh of that. A convex hull, which takes some geometric liberties and reduces the shape. You can definitely tell the difference in that convex hull from the original. Definitely much more coarse, but again, huge payoff if you're really trying to just get a small file. And then the box wrap actually is the absolute minimum detail, so that'd be very coarse. Again, you can wrap whole model, selected parts, and again, all under control of what kind of tolerance are you willing to accept in terms of resolution and how much the part may move by doing this. So defeaturing was one of the big ways that we reduce polygon count and reduce the mesh. The other one is what we call mesh decimation. So essentially, in the end of the day, basically remeshing the model with the goal of removing as many triangles as possible, all with the constraint of that user required accuracy. So that the user sets that maximum geometric change, and then to balance that, they set a target for decimation. And we have two ways of setting that target. That can be a percentage reduction that the user sets, saying that, hey, I want a 50% reduction in polygon count. And if CADfix can do that within the parameters of not going over the maximum geometric change that you've also have set, it will do that. You can also set a maximum triangle count. So you may say, I want 20,000 triangles and no more to mesh this model. And again, these decimation rules can be applied across the whole model or selected components if maybe you need less resolution in certain areas of the model, but more resolution in others. So this is an example of the percentage reduction. You can see the difference if you look at the mesh and how it's more dense on the left-hand side. And we've specified a 70% triangle reduction from the original to the result. And then this would be an example of setting just a max count. So again, if the max geometric change field allows us to remesh this model to this degree, we will do it and meet this goal. So we have a reduction here of nearly 200,000 triangles down to only 20,000 triangles. So once you got the levels of detail, you have some defeaturing and decimation options. Again, once I get to the product, you'll see that this is all incorporated rather automatically, and you can generate these different levels of detail meshes automatically based on the settings you have in each field. And you'll export to whatever VRAR, MR format that you work with. More formats are supported on the export side. We have the FBX, the GLT, GLB, JT, OBJ, the VR, ML, and XGL, ZGL. And then we also have a customized FBX export specific for Unity and another one specifically for Unreal. So automation and batch, again, I've talked about this. You'll see this once you get to the product. There's definitely automation just within the GUI in terms of loading up a model, having these different levels of detail that you have preset with some of these options, and just generating meshes and then deciding which one is most appropriate and experimenting around with those options, and maybe getting a finely tuned config file that you always use. And then you can also do that entire sequence of things in a command line batch option. So this could all be integrated into maybe a workflow of taking MCAD models down to different resolutions for the VR, AR, MR workspace. So in terms of a solution summary, talked pretty extensively about the key capabilities, but the idea being ultimately that you streamline the conversion and simplification processes required to repurpose these MCAD assets for the VR, AR, MR workspace, and optimize and automate that workflow. So that's the conclusion of the presentation. I'm going to go ahead and get into a couple of models here. So this is CADfix Viz. I have a model here loaded. I believe it was originally a step file. And it's talking about the automated meshing of levels of detail. So here I have those different meshes specified, and then I can open up the options panel here and see how they differ. The first one being essentially just the out of the box, keep all the CAD detail in the model and mesh it. Obviously, again, we always try to use as few triangles as possible when we mesh the entities, but we're not, removing anything. We're not defeaturing anything in this first mesh. The first one I have set to suppress holes, suppress internal features, and also to decimate the mesh with a max change of up to 0.73 millimeters. And then the second one, a lot of similar options, although we've added suppressing small bodies. Again, all of these controlled either by a size or some kind of max geometric change. Still decimating the model here, but you can see that the max geometric change is nearly doubled from the other panel. So I'm going to go ahead and just launch this. It's going to go off and create these meshes, and just to kind of give you a physical idea of some of the differences. You can see I have another model pulled up here. I'm just going to go ahead and generate the LOD 0 mesh here, which again is just the default full detail mesh on the model. And then to kind of see how some of these individually work, I'm just going to copy that mesh. And then on this second mesh, which is again just a copy of the first one, I'm going to look at some of the options that really are going to matter. You can see all the slots in this part in the back. So I think removing holes is going to give me a big payoff if I do that. You can see not only the slots, but there's a lot of other holes throughout the model here. And we're going to basically essentially suppress those holes out of the mesh. You can see just by doing that, we've gone down about 2,000 triangles. Removing internal features. It's going to look for, again, mesh triangles that are not visible. In this case, I specified a max size of nearly 6 millimeters. So if there would be an opening in this model, it will kind of span over that gap. Remove those. And then ultimately, a lot of the payoff comes down to decimating the model. Going to open up the geometric change a little bit here and accept as much as a 4 millimeter change in geometry. And in this case, I'm using a percent reduction of 70%. And we'll see how close we can get with that. But you can see that we've gone down from just with those 3 operations of defeaturing and decimating. We've gone from a polygon count of about 65,000 in this first one, and that's a visual of that first mesh as I click on it, down to a polygon count of just a little over 11,000 in this second one. So you can see, still capturing the major components, shape, features of this model, but just a lot more lightweight. So once you are happy, perhaps you're happy with this, just to give you a quick example of taking this out to, let's take this out to the Unity specialized FBX. It's going to go ahead and dump that model out to the FBX format, and the Unity, or the specific Unity format, really, which is a specialized FBX format. And now we'll go back and check in on this model, and you can see that the second one, the second level of detail here, Lot 1, has done a very good job. We've gone from a default of nearly 42,000 triangles down to a mesh of about 7,000 triangles. And by clicking on the two, you can see, obviously you see a difference in the mesh, but you don't see a huge geometric difference. Still, a lot of the detail is there. You just have a much more lightweight mesh. It's going to give you faster performance in your VR, AR, MR application. And then mesh 3, Lot 2. A little bit of difference there, and in reality, we only got about half, a reduction of about half the triangles from the second one, so we've gone from 7,000 down to about 3,500 triangles. So all in all, results that you could be happy with. And like I said, you can store these different LODs within the CADfix Viz database, but then there may ultimately be one that you go ahead and export out. So let's take the second one, which we're happy with, and we'll take that out to the GLTF, in this case, the GLB format. And we dump just that mesh. So, and again, all this can be automated in kind of a server type workflow, such that the conversion or repurposing of MCAD models is done automatically to these AR, VR, MR specific formats, mesh formats that are ready to use in your application. All right, that was the extent of the presentation. Kristen, I don't know if we have any questions to wrap up with.
Yeah, thanks, Steve. So at this time, we will hold a Q&A session. If you do have any questions, please drop those in the questions window. It looks like a few people did send some in throughout the presentation, so we'll go ahead and get started with those, and then we'll wrap up. So Steve, the first one, are you limited to 3 meshes? Meshes 0, 1, and 2 with different levels of detail?
No, you're not. That's what we start with, but you really theoretically can create as many as you want. So there's a little add button here in this tool that would essentially add, so right now I'm already on a 4th mesh. So you can add more, definitely. 3 is kind of where we start with, but for maybe when you're fine tuning all of these options, you may want to collect a lot of different meshes in the model, review all of them, and kind of hone in on what options you think are optimal for your workflow.
Great, thank you. The next one is, can this program remove features like holes and protrusions from the model?
Well, it does remove them from the mesh. The way the program ultimately works underneath is that it's not, you're never exporting CAD geometry in the end anyway. So instead of really removing things, what we're actually doing is suppressing features when meshed. So the holes or protrusions are definitely going to be gone from the mesh model, but would still exist in the CAD model. So you can see if I go back to a look at the CAD, get out of on this one, if I go back to the plane of CAD, you can see the holes are still in the CAD model. But what I've done is suppress them in the mesh representation that I created here.
Okay, great. Next question is, can the simplification technology be used to simplify a CAD model prior to migrating to Revit format?
A different CADfix product line would be applicable to that. CADfix PPS, which we did a webinar about a month ago on, that would allow the export of actual geometry representation, not just mesh. It actually has mesh formats in it as well. So if you do have a little bit of a need for the VR, AR, MR workspace, or if you just want to create a meshed faceted representation for downstream use, that it's able and that's enabled in there. But the PPS product is similar to that, very similar to this in the way that it can defeature model. So ultimately the answer is yes. It would just be a different CADfix product line that's probably better suited.
All right, it looks like we have a few more questions, so we'll go ahead and take those. With CADfix Viz, a mesh is stretched over the existing model, and we've reduced the triangle as needed. Is that correct?
Yeah, ultimately, there's a mesh, and then the decimation definitely reduces the triangles. So that's a targeted approach in the background that is essentially trying to remesh areas and faces of the model with less triangles. And again, that's a balancing act between the maximum geometric change that you're willing to accept, and then the other way of reducing the triangle count is really that defeaturing, which is more of a suppression of features. So if I suppress the holes, the face that the holes were in is then essentially remeshed without the holes. So, yeah.
Okay, we'll take one more question, and then we'll wrap up. Do you also convert metadata information like part names, versions, assembly structures, etc.?
Yes, that if the model has, we definitely have part names. This one particularly, yeah. So I mean, part names will be assembly structure, and part names will definitely be preserved. Different these different mesh formats have a little different way of representing them, but I believe in all of them that kind of information is preserved. So yes.
Okay, great. Well, thank you guys for joining us today. If you have any other questions, please keep submitting them in the questions window. We will follow up with you after the presentation. Again, thank you for joining us for the MCAD optimization for AR, VR, and MR application webinar. We will be sending out an email shortly with a link for you to rewatch the presentation. If you have any questions, feel free to contact us at info@iti-global.com, and we will be in touch shortly. Thank you so much. Thank you, Steve, for the presentation, and we hope you have a great day.
Yeah, thank you, everyone.